Hello friends, today we have with us Dr. Vijay Mohan from the National Chemical Laboratories, Pune, to discuss some of the aspects of nanotechnology, nanoscience and the implications of it for common man. So let me ask Dr. Vijay Mohan the first question: how does the nanotechnology help common man?
When you look at common man, the quality of his life, we have major concerns as our civilization progresses and as India is slowly becoming a developing country. We have major problems with respect to our development. For example, in India, we have several regions where we do not have electricity. Many states, many localities, we do not have drinking water. Water is contaminated by arsenic, by lead, by mercury. To provide pure drinking water to people, to provide basic health, to give energy, whatever energy is needed for development. So, we have problems. The way we generate energy is one example. When you generate energy by thermal power stations or by hydroelectric projects, most of these cases we also contaminate our environment. So, it is increasingly important to have carbon neutral energy generation. Nanotechnology has given clear evidence that there are methods where we can generate energy without any adverse impact on the environment. However, some of these options are costly. Nanotechnology is useful because nanotechnology is promising to develop certain materials with unprecedented performance. Without having absolutely no bad effect on the environment, we can generate energy. One example is fuel cells. Nanotechnology has given important materials. When you use these materials, fuel cells could be constructed, fabricated. You can generate, you can convert hydrogen to electricity by using fuel cells. Some of the bottlenecks in these development we have been able to overcome by using nanotechnology. This is one example. So, I would say that nanotechnology has given us unique materials. These materials will give you better performance than the conventional materials, whether it is for generating electricity or for storing hydrogen, or for detecting some of the environmental pollutants. All these cases we have been able to get some materials, and some of these will definitely affect the common man. For example, drinking water. I can talk to you about drinking water because nanotechnology has promises many nanostructured alumina kits are there. You put brackish or contaminated water from top and you will see that drinking water comes out, and this is not expensive. So, at least certain materials developed using nanotechnology are cheap for energy generation. So, I would say that nanotechnology there is an impact on the common man. However, it is very slow. To come to percolate to the normal middle class people, it takes some time.
Now, when you talk about nanotechnology's boon, we also end up getting into this debate that nanotechnology is also having certain pitfalls. The usage of the technology could be causing health hazards. Would you like to comment on this?
Yes, this is a very important issue because many people have unfounded worries. Nano being too small, so when it is too small, difficult to detect, and then the reactivity is also very high. So, some of these nanostructured materials can get it into our body, they can get accumulated, in body parts like the kidney, lungs. So, this fear is there, but this is a perception which is not really true. For example, asbestos. Asbestos, if you deal with that, asbestos fiber can get into lungs. Asbestosis is a particular disease because of that. Silica particles, very small silica particles can get into body and you can get silicosis. So, nanomaterials as such, I do not think there is any special hazard. However, since the particles are extremely small and the reactivity scales with the reduction in size, you will have to take precautions. But that is true for all chemicals, most of the chemicals we need in the laboratory, we have special precautions. Suppose you are involved in research in carbon nanotubes, you must have a mask, you should not inhale carbon nanotubes. So, otherwise what happened, there are a lot of fictional movies about nanotechnology, just like Michael Crichton's Prey, but they call it as grey goose. So, one of the important themes of nanotechnology is that you can manipulate atoms, you can take atoms, place it precisely at a particular location. So, this is very general. However, if you consider this as a robotic arm where you take materials in small dimensions and put it somewhere, and then they themselves overpower us because they can think, they can do some wonderful things which we humans cannot do. So, this fear is that finally you will get it in nanobots. Nanobots can cut all our contacts, they themselves will be much superior. So, tiny nanoscale submarines going through your bloodstream, getting into vital organs, these are all unfounded phobias. There is no scientific evidence for this. Nano materials like carbon nanotube, yes, sometimes they will have bad effects, cell growth, biology, proliferation of tissues, all these cases bad effects are there, but our data, scientific data for most of these cases are slowly coming out. So, there is no need to have a such a phobia. There are many positive aspects. Obviously, there will be some there will be some amount of negative impact. For example, gold small nanoclusters are wonderful for marking, as you can make for example detection. Okay. If all this gold gets accumulated into a particular tissue, obviously there will be bad effects. So, for biological application of nanotechnology, we must have sound data. For Europe, they have a special program, assessment of the environmental impact of nanostructured materials. One of the important aspect is that all these research has come probably last 10 years. So, maybe next 5 years, 10 years, more data will be available. Toxicological issues of nanostructured materials, work is going on. So, without having such evidence, it's easy for one to go and generalize, telling that nanomaterials are much more damaging, environment will be contaminated by all the nanomaterials. I think we must not get it into such a phobia. As scientists or as engineers, we must look at data available and go to meaningful conclusions. The one example is that someone injected a small amount of carbon nanotube on a rat. They observed that cell proliferation. They immediately made a conclusion that, look, carbon nanotubes can cause cancerous growth. The actual truth is that there was a surfactant which was used to dispose the carbon nanotubes, and later there was a study which showed that that particular surfactant was more responsible for cancerous growth. So, the important conclusion is that we do not have sufficient data to generalize any of these issues, and work is going on. Maybe another 5 years, 10 years. Interdisciplinary research in this area is a dire need. That is all we can talk about the environmental impact. Just like greens, So, there are many groups, they just want to, they have a pessimistic view, anything nano is dangerous, anything nano is bad. That we should not generalize. We should also not go to the other extreme case that for everything nanotechnology is a panacea. We can have faster computers, we can have better medicines, we can have all sort of our problems solved by nanotechnology. But positive effects are there. For example, someone has made a artificial tree. So, nanotechnology has been used to make this artificial leaf which absorbs carbon dioxide, 1000 times more carbon dioxide than a natural leaf. So, this has been experimentally proved. You make a synthetic leaf, the synthetic leaves absorbs carbon dioxide. So, if you have such leaves or such trees on 1 acre area, obviously the carbon dioxide accumulated could be removed. So, this is one positive example. Similarly, nanotechnology has been used to make a zero emission building, zero energy building. Singapore, there is a zero energy building I talked to you about the other day. So, you have a huge flat structure which is connected to the connected to the grid. However, whatever energy you take, you can give it back because this building has got solar tiles. It can absorb sunlight and generate energy. This energy could be used. Similarly, someone has come up with a treadmill. As you walk in this treadmill, you generate energy. There are piezoelectric materials down, nanostructured materials, and after running for 1 hour, you can take your cell phone and charge it. So, the concept is beautiful. So, definitely the life of a common man will have a profound influence by nanotechnology. It is very slow to see. We will have to wait for 10 years because what happened, all these scientific developments, the incubation time is quite large, especially to the average person.
So, since you have put it very nicely that we will have to work on the bad aspects which have been always pointed out.
Yes.
And it is too premature to actually talk about the negative aspects and think about the positive aspects. So naturally it comes to the next question, that the children around you, they are interested in knowing what are the opportunities for a student in these areas, and how exciting it is to work in these areas.
We can look at this from two different points of view. One of them is that nanotechnology is spectacular because it involves the right combination of other fields. You need to have strong physics, you must know solid state physics, otherwise it is very difficult to understand what is quantum confinement, how the interesting properties arise from these materials. And the second aspect is that utility aspect. So, in any areas of science you have got curiosity and utility. Both should be blended so that we can motivate young students. So, when we talk about undergraduate level of education, we must mix both this curiosity and utility. Utility, for example, global warming. Can we use nanotechnology to alleviate problems of global warming? Similarly, drinking water, another issue, availability of electricity, another issue. At the same time, some of the students, especially for academic people, they may not be interested in the industrial implications. They may be more interested in curiosity aspect. For example, when you make 1000 atoms of gold or 5000 atoms of gold, why does it behave like a semiconductor rather than a metallic structure? So, electrons are already there in that. When you look at the deployment of all these electrons and their collective behavior. So, how you get basic properties changed with the size and shape. This is something very important. For example, in chemistry, we normally look at periodic table and look at all the metals, melting point. Melting point is a constant. Now, nanotechnology says no, it is not a constant. It varies with the size, it is varies with the shape. But what is perhaps more exciting is that each of these nanoparticles, when you assemble in a particular way, their behavior again changes. So, the collective properties, if you can tune it for getting some beneficial effects, it becomes all the more exciting. So, many new materials created using nanotechnology, they do not have counterparts in the bulk. That is why it becomes all the more exciting. For example, energy, as I told you, very tiny fuel cells, very tiny batteries, they can give you large amount of energy with very high efficiency. So, curiosity part and utility part can be combined. Certain areas are grey, we do not have answers. Temperature is a macroscopic average property. So, when you look at a large porphyrin molecule designed for an electronic circuit, that is a molecular electronics, what is the temperature in one particular region? We do not know, we do not have answers for that. We cannot define the temperature of a single molecule. Our present science, we just cannot explain. However, excitement can come because certain concepts are entirely different. These concepts are not there in our conventional textbooks. Semiconductor means we always have a band gap which is constant. So, every textbook will talk about silicon having a band gap of 1.1. Now, the student comes with this mindset, look, silicon means band gap is 1.1. So, when you tell them that, look, no, I can make silicon with 1.2 band gap, 1.3 band gap, and I can tune the band gap, this could be something to excite students. So, the curiosity part and the utility part, if you blend it properly, students will definitely be excited. Plus, these should also be linked with major issues, global issues, such as generation of energy without any environmental contamination, whether we can eradicate poverty from all over the world by, people talk about pill, small nano pill for dinner. We do not have to spend 3 hours and have a detailed dinner, we just have a small tablet. Whatever basically you need is already there. So, the other way we were talking about Drexler's concept of molecular assembler. What it does is take atoms and put it. So, we can always excite students by telling that, look, we have all the waste material, there are also carbon, hydrogen, nitrogen, oxygen. So, we can do a dissection, remove all that atoms and create whatever you want. Hydrocarbon has got carbon, hydrogen. So, this is one issue. All global major issues should be linked with whatever we teach in our basic academics. So, we can link this with, we can excite students by making this connection, whether it is for energy or it is for environment or it is for medicine. So, humanity as a whole, we all have certain general major issues. If it is linked with that, it becomes easier because everyone wants to glorify their work. It becomes easier to link, and also you can link with the society's benefit.
So, now very nicely you have actually put that interdisciplinary areas are the main reason why this nanotechnology is taking over, and you need to be perfect in at least one of these areas, so that you can collaborate with others.
Exactly.
Very nicely put. But the question is, if you are a trained manpower in nanotechnology, how do you actually look at industrial applications, or industry as such, how it looks at nanotechnology? So there are two questions in this one. One is, what are the opportunities in the industry, and how does industry look at nanotechnology?
Yeah, see, the Indian industry, if you look at their mindset, they are still little hesitant to enter into nanotechnology. However, if you look at strategic areas like space or defense, they have core competencies in nanotechnology. For example, missiles, or if you look at coatings, carbon nanotube based composites, because you can have so much of strength on these materials, you can tune them. Radiation resistant materials can be developed. So, carbon nanotube based composite is a major theme where strategic people like space and defense, they have come in a big way. For example, this Kanpur, there is a defense lab. They have a huge program to make composites. GE has got a major program again for carbon nanotube based composites. The point is that since carbon nanotube has got highest Young's modulus and the strength can be tuned, it is easier for us to make lightest materials with stronger mechanical properties. So, this is one. Automotive industry on the other hand, they are little more technology savvy, but they do not want Indian academics, Indian nanotechnology labs to directly contact. Maybe they do not trust us much. For example, talk about Toyota. Toyota cars, they use different type of sensors for whether it is rods, bumpness, or rain, it is going to have a what you call a humidity sensors. So, 60, 70 different types of sensors are integrated on a vehicle. Honda has last year unveiled a green car. Green car means totally green. Environment is concerned, it will not affect environment. However, this car is so expensive that maybe a Japanese president or only some of these world leaders can afford it. This car, they want to sell it, they put an advertisement with a Hollywood actress, because by looking at the actress, people will be interested to buy the car. So, the car is a green car, nanotechnology has been used, but it is too expensive. So, automotive industry is concerned, there are certain small components where nanotechnology has given very important advantage. In terms of the total number of such materials or such components manufactured and integrated on a car, and then to sell it at a low price, these are some of the issues. So, if you talk about Tata Motors or Mahindra and Mahindra, they all have their own nanotechnology program. But to begin with, they do not want to come in a big way. They want to put small components like, like you do not need a wiper. If you have a hydrophobic coating, nanostructured coating on the glass, you do not need a wiper at all. Now, how durable this coating is, people want to evaluate it. So, since nanotechnology itself is fairly young, issues about material durability, reliability, those are all the issues which they are waiting. So, it is also unfair for us to expect a huge industry to come and then take up all this. But as far as I know, automotive sector, there is a very positive impact on nanomaterials. Coatings is quite easy because we can expect coating there is a large amount of application. Number two, we will need large amount of materials. Gold, silver, few milligrams when you make reliability, reproducibility, these are some of the issues which industries are worried about it. But for students getting job, yes, slowly Indian industries are opening out more and more for absorbing people from nanotechnology. But it is always interesting to do nanotechnology with a basic expertise in masters in physics, chemistry, biology. So, after your BSc you go and study nanotechnology, MSc, nanotechnology, MTech, there is a problem because you will have big gaps in your knowledge. That is not good at all. Second issue is that engineering and science, we have a huge gulf. We need to again fill it that. So, it is always better that a nanotechnology program where scientists with various background, engineers, they all come together. An organic chemist should make a material for an electronics engineer to test for molecular electronics. So, this interdisciplinary aspect of nanotechnology itself is exciting.
So, you were saying that the interdisciplinary approach as well as bringing engineering and science together is the way to go about.
Exactly.
And taking a cue from your discussion and being an expert in energy issues, I would like you to talk about your research on fuel cells and related topics of hydrogen storage, which are very close to your heart, and you have been working with this with the Indian government.
Yes.
And how you envisage this particular development is going, and how many years it would take for us to actually replace fossil fuels?
Oh, this is a very long question. We don't, I mean, I don't think in near term we can replace fossil fuels, but what is important is that government is thinking of some incentives for renewable energy. So, for example, we have a lot of coal. Coal is very dirty, and we conventionally we can generate electricity from coal, but the problem now is that everyone is watching us. India is the 4th most greenhouse gas emitting country. So, well, maybe if you think about Australia or US, they have a different perception. Okay. So, if you look at the India and China, we are growing, our economy is becoming strong again, average growth rate we know, and we have a huge population. So, to provide energy, drinking water, basic amenities to this huge population is a major issue for us. So, we need more and more energy, our growth rate is always high. Okay. There are two issues. Number one, we find that population is shifting from rural area to big cities. It creates associated problems, Bangalore, Calcutta, Delhi, all these metros, more and more people are coming. Drinking water, electricity, there is a problem already we have. So, we need large amount of energy, whatever is, I mean, even if affects our environment, we need to generate energy, because otherwise we just cannot go ahead. That is why country is thinking of nuclear reactors. We are making many new nuclear reactors. We are making also many important coal powered, I mean thermal power stations, because there is no other way. At the same time, we are aware of its bad effects. So, government is trying to put large amount of money for funding renewable energy research. Renewable energy research like biodiesel, biomass, all these are important, but they are not at a stage. Fuel cells on the other hand is a stage where nanotechnology has given some crucial materials. So, if you look at fuel cells, what are fuel cells? They are electrochemical devices. You supply hydrogen from one side and you supply oxygen from other side, and you generate electricity without having absolutely no environmental contamination, nothing comes out. So, it is a clean energy, we talk about premium energy. For sustainability, this is important because we can generate energy without any environmental contamination. But then why are we not using fuel cells? It is too expensive. And why fuel cell is too expensive? Because fuel cell uses certain materials which, although all those materials are expensive. For example, in a fuel cell you have electrodes, you have an electrolyte, and you have a particular material known as carbon paper, bipolar carbon plate and carbon paper. All these fabrication is expensive, and then you also use platinum as a electrocatalyst. Platinum is again very expensive, not available at all. Now, if nanotechnology generates materials, cheap materials, people have shown conducting polymers can be used to replace platinum. Similarly, a membrane which we use as an electrolyte is very expensive. This membrane is made only by a company, I mean what we call it as Nafion. Nafion is a material prepared only by DuPont. So, it is too expensive now. Nanotechnology has generated materials which can replace these. Similarly, another important issue is that the conventional material which is used in a fuel cell, which is Nafion, this will work only up to 80 degrees Celsius. However, if you want to use hydrogen, now hydrogen is not available. So, hydrogen is generated from steam reforming, that means fossil fuel. So, it will have some amount of carbon dioxide will remove, but it will have a small amount of carbon monoxide. Anywhere you generate hydrogen from conventional fossil fuels, you will always have carbon monoxide. Carbon monoxide poisons platinum. So, carbon monoxide has to be removed totally. If you have a fuel cell which works at 100 degrees, 120 degrees, then carbon monoxide will not poison, because at this temperature carbon monoxide dissolves. So, it is extremely important that you must have cheap fuel cell. So, for making cheap fuel cells, number one, we have to remove platinum, we should have better materials, and those materials are available by nanotechnology. Number two, we must get rid of this membrane. A membrane which functions at 100 degrees is always essential. So, nanotechnology, and in fact our own lab we have made a membrane, NCL, our polymer scientists, they have made a membrane, but this membrane has to be benchmarked with Nafion. This takes time, durability of this membrane has to be seen. So, I would say that there are certain materials developed using nanotechnology. These materials have so far shown superior properties compared to conventionally used materials, and they are cheap. So, by making more and more 1 kilowatt, 5 kilowatt, 10 kilowatt systems integrated, we will be able to learn various aspects of these fuel cells, and then we will be able to make cheaper fuel cells. So, government is trying to put large amount of funds for hydrogen energy research on one side, then solar and wind energy research on other side. Because government, I mean government, and not only government, even our academic think tanks, they are all of the opinion that for sustainable energy, we must go for solar or wind coupled with fuel cells. Because solar or wind you use to generate hydrogen from water, and this hydrogen can be used as a fuel cell without any emission, you will be able to have a sustainable energy option. So, hydrogen economy, in fact 2 years back government made a statement that 100 million cars with hydrogen we want to put it in Indian roads. Now, it is found to be almost impossible. So, there is a slight reorientation in our focus. Prime Minister has a special committee known as Committee for Climate Change with respect to India. So, in December when Copenhagen there is a meeting, our Prime Minister will be presenting all this. So, last week this committee has 8 special programs, and one of the programs, one mission program is solar. Our target is that by 2020 we want to generate 20 gigawatt only from solar, photovoltaic. Of course, photothermal, that is also very important, and the government is now planning, but we do not have enough expertise. So, for photovoltaic is concerned, government is trying to give so much of incentives. After some time, there will be, I am sure, maybe couple of maybe $0.1 per kilowatt. These are all the targets kept with government.
Now, one topic which is always to be looked at, and also India getting into the nanotechnology at a very later stage compared to the developed countries. Being a practicing nanotechnologist, I would like to get your opinion for the common man or common people who are actually listening or hearing this program. How do you put Indian nanotechnology programs, nanotechnology per se, vis-a-vis developed countries like USA, Japan?
Yeah. I think if you look at the development in US or Europe, they are far ahead. Even China, Korea, Singapore, these countries are far ahead. We have a large number of nanotechnology researchers in our country, but their productivity level, innovation level is quite low. So, if you look at innovation index, India comes 40 or 41. Even Korea, China, Singapore, they come in first 10. So, the reason is that some of our people, they are very good. They do excellent work when they are outside. When they come to our country, maybe the environment is not conducive to them to test their original ideas. Many of their ideas, if these ideas are abroad, it becomes easier for them to test it. Our infrastructure maybe takes too much of time to develop. So, it is much better. For example, someone almost a year back, someone came with a plan. Can you make a kidney out of carbon nanotubes? You intertwine carbon nanotubes, make an artificial kidney and see. But to practice this in our country, to implement those ideas, it takes an enormous amount of time. We have centers for nanotechnology, but these centers are isolated, and the centers do not allow people to come from various places and test. For example, in a remote university, somebody may have a brilliant idea, but to implement this, it takes large amount of time. So, we have many researchers in nanotechnology, but the average, if you look at the output, quality of the research, I think we need to do much better work.
So, at this point, it's an interesting discussion we had, and I would like to actually thank you for taking time to explain everything.
Yeah, it's
thank
my
you.
pleasure.